Imagine this, you're 35,000 feet up, sipping your tiny soda, when suddenly, silence. The engines on your massive commercial jet, those roaring beasts, fail star. What then? Does the plane just plummet, a giant metal brick falling from the sky? The very thought sends shivers down your spine, right? It feels like an immediate, catastrophic disaster. But here's the shocking truth, a modern airliner, even with both engines out, is designed to keep flying. It's not magic, it's brilliant engineering and an understanding of fundamental physics. Prepare to redefine what you thought you knew about air travel. So, if the engines aren't pushing, how does it stay up? The secret lies in something called lift. Airplanes fly not just by thrust, but by moving through the air. The shape of the wings, that aerodynamic masterpiece, creates a pressure difference. Air flowing faster over the curved top surface means lower pressure, slower air underneath means higher pressure. This pressure differential literally sucks the plane upwards, creating lift. Engines provide thrust to move forward, but once you're moving, lift takes over. Without thrust, you lose speed, but not instantly the ability to fly. A plane isn't falling, it's gliding star. Think of it like a kid on a skateboard rolling down a gentle hill. They're still moving forward, just losing altitude. Planes use their forward momentum and the force of gravity to maintain airspeed. This means the plane exchanges altitude for distance. Every aircraft has a glide ratio, how many miles it can travel forward for every 1,000 feet it drops. A commercial jet can glide surprisingly far. This isn't a freefall, it's a controlled descent, giving pilots crucial time to react. The danger isn't falling, it's managing the descent. But wait, why do planes even have multiple engines if they can glide? Because redundancy is the golden rule of aviation. Almost every commercial jet has at least 2 engines, with many having 3 or even 4. This isn't overkill, it's a critical safety layer. Losing one engine means increased workload, but the plane can absolutely continue to its destination on the remaining ones. We're not just talking about engines either. Most critical systems, from hydraulics to navigation, have multiple backups. Aviation engineers plan for failure, then add 3 more plans. What good is all this engineering if the humans flying it can't handle the pressure? Turns out, pilots are the ultimate redundancy system. They undergo rigorous, continuous training for every imaginable emergency scenario, including total engine failure. This isn't a fly-by-the-seat-of-your-pants situation, it's a highly structured procedure. They immediately consult checklists, communicate with air traffic control, and begin executing a predefined plan. Their calm, practiced response is what turns a terrifying incident into a controlled, survivable event. They're not just pilots, they're problem-solving machines. Still skeptical? Let's talk real-world proof. Remember US Airways Flight 1549, the miracle on the Hudson? Bird strike, both engines out. Captain Sully Sullenberger glided an Airbus A320 with 155 people on board to a perfect landing on the Hudson River. Or what about the Gimli Glider incident? Air Canada Flight 143, out of fuel mid-flight. Pilots landed a Boeing 767 successfully on an abandoned airstrip. These aren't lucky breaks, they're testaments to incredible pilot skill, aircraft design, and the inherent glide capabilities we've discussed. The stakes were real, the danger immediate, yet everyone survived. But what about electrical power for instruments, lights, and flight controls? If the main engines are out, how do these vital systems stay alive? Spoiler alert, there are backups for the backups. Most modern jets have an auxiliary power unit, or APU, essentially a small jet engine in the tail that provides electrical power and air conditioning. In a dire emergency, some planes can even deploy a ram air turbine, or RAT. It's like a mini windmill that pops out of the fuselage, generating hydraulic and electrical power from the airflow. Critical systems are never without a power source. The plane itself is a fortress of engineering ingenuity. Beyond engines, the airframe is designed to withstand incredible stresses. Control surfaces, like rudders and elevators, often have multiple independent systems, mechanical, hydraulic, and even electric, to ensure that a single failure doesn't cripple the aircraft's ability to be steered. Wires are routed separately, hydraulic lines are duplicated. Engineers simulate every catastrophic scenario imaginable, then design layers of safety to prevent it or mitigate its impact. Every rivet, every bolt, every circuit is part of this incredible, life-saving puzzle. And what about the fuel itself? While engine failure can be fuel-related, planes carry far more than just enough to get to their destination. They have mandatory reserves, fuel to fly to an alternate airport, plus additional holding fuel. This isn't just a buffer, it's a legal requirement designed to buy critical time. Plus, modern fuel systems are highly sophisticated, distributing weight evenly and allowing cross-feeding between tanks. Even in a fuel emergency, the plane isn't suddenly out of options. The careful management of this precious resource is another layer protecting you in the air. So, how often do engines actually fail catastrophically? Thankfully, it's incredibly rare. Modern jet engines are marvels of reliability, built with exacting precision and maintained with obsessive care. Advanced monitoring systems constantly report engine health, allowing maintenance crews to address potential issues long before they become critical. Statistically, you are far more likely to experience mundane travel inconveniences like baggage delays than a dual-engine failure. The system works precisely because every possible failure point has been anticipated, designed around, and drilled into the consciousness of every pilot and engineer. It's truly amazing. Next time you're flying, look out the window. Remember that immense machine isn't just brute force, it's a symphony of physics, engineering, and human skill. The thought of engine failure might still be scary, but the reality is that countless layers of safety, meticulously designed and rigorously tested, are there to protect you. From the aerodynamic lift of the wings to the redundant power systems, from the highly trained pilots to the constant monitoring of engine health, every single element is working in concert to ensure that even in the face of the unthinkable, your plane won't fall. It will glide, it will be guided, and it will get you down safely. That's the real miracle of modern aviation. Fly safe.